Good afternoon, everyone. This is the second lecture of this 2-week national training on the environmental practices and renewable energy utilization scheduled between January 5th to 14th, 2021. Our second eminent speaker is Mr. Dwipen Bor, sir. He is the Managing Director of GSES India Sustainable Energy Private Limited, New Delhi. This firm is based in New Delhi, India, and providing the renewable energy consultancy and training services. So, welcome, sir, for this today's session. And now I request Dr. S.R. Kabante, sir, Principal Investigator of the NAHP, Dr. PDKV Akola, and the Program Director of this training program, to welcome Dwipen Bor, sir, for this session.
Sir, namaste. Good afternoon. Sir, welcome to this afternoon session of this 10 days training program. So this is NAHP, National Agriculture Higher Education Project.
Yeah.
And 3 years back, that NAHP, National Agriculture Higher Education, ICR New Delhi, they have sanctioned one project, capacity building and skill development in renewable energy. Especially our department is unconventional energy sources. Actually, it is renewable energy engineering in 15th committee of ICR. We decided to change the name of our department. And in our department, we have MTech program, then PhD program in renewable energy sources. And our activities are related. We use these renewable energy sources. We integrate these renewable energy sources with the agriculture community. Is how to use this renewable energy technology in agriculture. So once again, welcome you, sir. Today, our second eminent speaker for this training program is Mr. Dwipen Bor, sir. He is Managing Director of GSES India Sustainable Energy Private Limited, New Delhi. This office is situated at New Delhi, which provides the consultancy on renewable energy and also provide the training services. Dr. Dwipen sir, he has a 30 years experience of renewable energy planning in project management, consultancy and training. Dwipen sir has had business experience throughout several countries with clients from the corporate sector, then government, multinational organizations and NGOs. He has authored and co-authored many books and training manuals, especially on solar photovoltaic system, design, then its installation, how to maintain and inspection, and more than 150 technical and professional reports he has written. And there are several publications and papers in the technical and magazines and journal he has published. Before founding GSES India Sustainable Energy Private Limited, along with Job Stapleton and Susan Neil in 2012, Dwipen sir served in the Assam Energy Development Agency as a project manager, then IT Power India as head, Renewable Energy Solutions, and ICLEI South Asia Secretariat as Director, Energy and Climate. Dwipen sir, he is a basically mechanical engineer, and he did his post-graduation in renewable energy from Oldenburg University, Germany. So we are very grateful, sir, that you have agreed and accept our invitation as an eminent speaker, guest faculty in this 10 days training program. So once again, welcome you, sir, for this training program. And today he will deliver his lecture on environmental practice on photovoltaic systems, advances in photovoltaic system, solar photovoltaic technology, entrepreneurial potential. So thank you, sir. And I request you to start your presentations.
Okay. Yeah. Thank you, sir. Thank you all, Swati, and for getting me for this this seminar, because earlier I missed once. I could not come, I think last year or 2018, I think. Yeah. So that time I wanted to come to your campus, but that was not possible because I stuck up in Uganda somewhere.
We invited in our program, one of the
international conference.
Yes, I could not make it out because I was in Uganda that time, and somehow I had to delayed or deferred my travel there because of the work. So I could not make that. So I feel sorry for that. I know your university from my time in IT Power, because two of your students that time and one I think lecturer, he is still working there. So they worked with me for some time, and he is still working in industry. I think both of them, they were very excellent professional, and then that is why I know the university for the good cause. So I know that your students and teachers are very well, and they are very good for the subject. They know the subject. They are very professional, and then I think that is because of your teaching, probably, definitely, and your environment in the university. That is a very, I think, that is why I am very happy to be here again to share my experience related to solar photovoltaic. So I will now then, if everybody saw me, I will put off my video. Then if there is a disturbance or so, then it will be I think better. So what I'm going to discuss today is basically it is I will give you some um, uh, so it will be introduced. I will introduce my company first, then I will discuss about the global PV market growth, what is happening across the world. Then what is the potential of employment generation in this industry, photovoltaic industry in particular, and then what is the opportunity in India. Then what are the business areas in the photovoltaic sector. Then what are the different type of photovoltaic applications uh, for doing business, of course. Then what are the PV project development phases and skill set requirement. Then also I wanted to explain, because the success of a project always connected to proper skill of the people who execute and plan the projects. So that is why the success or failure is linked to, normally in solar photovoltaic sector, linked to human skill, basically. So that is why I want to show you or discuss you few things, why PV system fails and how it is linked to the skill issues. Then I will present you some case examples. Then also I want to discuss, if time permits, that what are the risks associated with solar PV project for its success, and what are the focus areas that one has to keep in mind to mitigate those risks. So then finally, I will summarize with what is the quality system that requires for sustainable growth. So first, my company, that is GSES. So in full, it is called Global Sustainable Energy Solutions. We found the Indian company in Delhi, 2012. So in 2098, this company was established in Sydney, Australia. So we carry the name as well as the credentials from the company. Then we found it along with the founder of the original GSES, Jeff Stapleton. So he and I knew both when I was working in IT Power. So we are friends. So we decided to start the Indian office in 2012. So we work both in off-grid as well as hybrid and on-grid systems, not only photovoltaic, but we also work on solar thermal. We also work on wind, very little, not much, and also work on micro hydro, mini hydro, etc. So one of the major activities in our company is training. So we provide professional trainings for basically to connect the academic student to the industry. We give them the knowledge and the practices or skill that requires in an industry, whether it is a engineering industry or consulting industry. So that helps, and also some people also found that it is very helpful for their higher study abroad. So that is what we do. We also support our training programs through some books. We have many publications, particularly those are engineering publications for professionals, not for academic purpose. But some of the books are used in New South Wales University in Australia. There is a textbook for them. So we have books on grid connected PV system, both Indian version, international version, Australian version, US version. Then we have books on off grid, again Indian version, Australian version, international version, and US version. And we have books on grid connected PV systems with battery storage. Then we have books on solar pumps. We have books on microgrid, etc. Then we also have one book on entrepreneurs. So that was one publication was done in India and one is done in international version. One is there. So that is what my company is. We work about 40 countries across the world, of course, in different capacities for consultancy services in some countries, for training services in some countries, and for publications in some countries. So now let us get into the subject. So photovoltaic market is growing more or less exponentially. Particularly, the growth is very fast from 2008-9. Before that, the growth was very slow. The one major reason was the policies taken by the government, not really in a mass scale across the world. Only few countries like Japan, US, Germany had some policy. So India had policy only on off-grid. So from 2008-9, most of the countries has taken adopted policies to increase the use of solar photovoltaic after a very successful program in Germany. Then the price, the volume has increased because of the policy slowly. Immediately price has gone down because of the volume. Then many manufacturing sectors has taken big plants, particularly Chinese manufacturers became major manufacturers. Germany was the leader. India was also leading that time in 2000 until 2008-9. India was more or less at top. So India used to export panels to European countries, US. But after Chinese has started developing those modules in a very large scale, so Indian market has gone down. So that was history. I think India still can do better. So I think initiative has taken. Some companies are now, I think, doing very good progress, like Adani's, Wari, Bikram Solar. They are at par the Chinese manufacturers. So that is a good sign. So overall installation capacity till last year, last year, now it is 2021 already. So, but I have only data till 2019. So there was an installation capacity of 617 gigawatt in world, and then so 9.8 gigawatt. That is the for the non-IES IEF member countries. But in any case, the total capacity was 617 gigawatt and plus 9.8, so it is 6.27 gigawatt. So most of the countries, like there are 10 countries, I think you can see what is the total capacity as well as the annual growth. That is first left-hand side, you can see what is the annual growth. Here I took this slide from IE, and that the comma is basically full stop. So don't get confused. 30 point comma means 30 point actually 1. So it is a 30 gigawatt China, European Union 16 gigawatt, United States 13 gigawatt, India almost 10 gigawatt. I think last year. Then Japan 7 gigawatt and so on. So cumulative capacity, China is already at 200 plus gigawatt, European Union 131 gigawatt, United States 76 gigawatt, Japan 63, Germany 49, India is 42 gigawatt. So that is where the India stands. Now you can see that the growth rate, you can see the significantly from 593 in 2019 to 1582 gigawatt in 2030. That is the projected growth. So this means that if you look at today here, it is somewhere here, 600 plus gigawatt. Then this growth will be again keep on remain as an exponential growth. So that can go up to 1600 gigawatt. That means there's a lot of potential in terms of business across the globe. So China, India, Germany is still growing. India will grow much faster. I think India will surpass Germany very soon because Germany has limited areas, limited being a small country. India is a very big country. We have a lot of land, lot of water, and lot of buildings that where the photovoltaic can be installed. So I think India, US will take a lead. China, of course, already far ahead of us. But we have also a good target by 2022. So I think India will also grow very fast. Now look at the from employment generation. So as per IRENA data, so about you can see 3605 thousands. That means 3.6 million jobs was created in solar photovoltaic sector. So, but other renewables as well, so liquid biofuel has a 2 million, hydropower has 2 million, wind energy is 1.1 million. The reason why solar photovoltaic generates more job is solar photovoltaic is a decentralized mostly. So wind, like you have 1 kilowatt, 1 megawatt, 2 megawatt, 3 megawatt wind turbines, but solar can be started at few watts. Even you can have a 100 watt, you can 50 watt system, then auxiliary system, then some kilowatts of rooftops, and also it can be some megawatts land ground mounted. It can be also gigawatt. So the scale or the volume in solar is much diverse, and then employment opportunity, of course, across the small or big system, but a smaller system employs more people in terms of field work or whatever. But you need more management people, more project managers, more designers for large plants. So it is a mix of different type of human capital, or I can say it is a skilled manpower that is required across the solar energy solar photovoltaic sector, which can be a small systems, or maybe some products, or maybe a large system. Again, within large system, some will be ground mounted. Now there are new technologies coming up. It is floating solar and mini grid solars and other things. So now look at the 10 countries where the employments, like China, Japan, United States, Bangladesh is one, mostly through solar home systems. Bangladesh mostly known for solar home systems, but nowadays also they are coming up with a lot of mini grid systems and rooftop system as well, and some megawatt scale projects, 1, 2 megawatt, 10 megawatt kind of. Malaysia is another one after India, Turkey, Germany, Vietnam, Chinese, Taipei. So these are the major countries who employs most of the people in solar photovoltaic sector. Then this I have already presented, 3.6 million globally, China 2.1 million people, India 0.1 million or 115,000. So India is still need to grow. Of course, it is growing, and then I will show you how much potential is there in India. You can see there are more data available in US as far employment generation is concerned. You can see here number of PV installation is growing like this very fast, and also now number of employment generation is also going fast. So in India, so 2010, I think long back, the MNRE has done some study. They prepared some report with CII. So then they projected what are the skills or human resource requirement in this overall renewable energy sector, not only PV. So certainly project development is one area, construction and installation is one area, operation and maintenance is a big area, then marketing is another area, research and development is another area, then manufacturing is another area. So that time manufacturing was the last, but I think today, I think after the Making India and the Atmanirbhar Bharat, so I think manufacturing should come first. But in any way, so these are the sectors or areas where you need human capital and that requires a good and highly skilled human capital. Those are the areas. Now look at some numbers. What is projected numbers by 2020 based on the National Solar Mission information? So there are some calculations, some estimation. Some has already happened. About I think 30% achievements we have already now, but the rest of the 70 or 40 still 60% to grow. So you can see in operation and maintenance, the predicted skill human required is 81,000. Then semi-skilled people 182 lakhs. Then business development 70,600. Design and pre-construction 28,000 plus. Construction and commissioning skill again 182,000. And construction commissioning semi-skilled people 624,000. So these are some numbers, but estimated you can make it out how much will be there. So if you add all of them, I think that will be how much? About more than 1 million. But in any case, that is by 2020, then industry will keep on growing, of course. Then by 2020, if we achieve about 100 gigawatt, then that will only not saturated, but it will only grow further. Of course, depending upon the policy of the government. I hope government policy is always positive for renewables and solar, so it will remain positive. So there are difficulties, again, challenges while delivering training, particularly in solar, that is related mostly on solar photovoltaic. So there are some surveys done by NRDC and CEW, I think 2017. So this survey shows from different manufacturers, different industries, it's an industry survey. So 83% people from the industry says the skilled people are not available, which is a big challenge. So I have been there in the industry for last 30 years. I also have the same opinion. So then salary offered is too low. So there are, the reason is solar photovoltaic, solar PV business is not very stable, was not very stable. I think still that competition is there. So consistent work is not there. So people are not employed fully. So when a person is not employed fully, so the employer will find it difficult to pay them higher salary. So if a person is not engaged in work, that is the one major reason, I believe. So not enough platform to advertise for jobs. That is another reason, which is probably not very true, but maybe solved easily through all social media and everything. Then proximity to training institute is another, I think, difficulties found by the industry. For example, we conduct training only at the New Delhi, and many people come from abroad, even from Middle East. We have maximum people from Kerala, from Tamil Nadu, and from Arunachal Pradesh, Bhutan. So those people have to come to Delhi. So there is no nearby training center or something, and it requires a lot of infrastructure for training. And online training is there. It is possible to provide online training to anywhere, but online training is not always considered to be adequate for giving you practical knowledge. So in this case, I think the universities like yours can play a very big role, strengthening its more practical oriented trainings, short trainings, not necessarily a course, because course requires a lot of different type of effort and skill. But some training and facility for providing practical training, professional training could be a very good help. And then some people also see it as a poor career growth path, which is not really true for many people that we see. So when you have a good training and good skill, and then you can actually prove yourself, a better human capital in the industry, then I think your career growth will never stop. It applies to everybody, every field. That work conditions are too demanding. That is true. Solar is something that, particularly when you work in the field, you have to work under the sun. So you cannot work in a. Only few people can do it who actually does design and other things that they can do it in house under a roof. But most of the people, so they have to work under the sun. So it's difficult always. Whether you work in the site or installation location. So it is a tough job. Now let us see what are the business areas, what are the opportunities in photovoltaic sector. So if you look at the business areas, those business areas can be broadly divided into 4 areas. So one could be product-based. I'm talking about after manufacturing. I have not included here the manufacturing. So of course, manufacturing is also a business opportunity, but it is for the investors, large investors and large companies. I'm just focusing here for general people or who just going to be completed the academic study. So one business opportunity is product-based, maybe some small systems, solar home systems, solar lanterns, maybe PV modules, inverters. So those, I think, products are a great demand nowadays because the market is growing. Because there are so many companies, small and big, coming up providing product solutions. So if you want to buy a PV module now, you can easily contact someone to get the modules at your hand. Earlier, it was very difficult. Only manufacturers used to supply those modules. Then if you want to buy a very small system, it was not a priority for the manufacturers. But now, even you want to buy one single module, you can buy it. Inverters in the same way. So there are so many suppliers, and then still the opportunity is there to do this kind of business. Another important aspect is, I think, structure. Structure is a local business. So because if somebody make a structure in Chennai, it is difficult to transport it to Calcutta or Delhi or somewhere, but structure can be fabricated locally. So that is a decentralized business. So it is easy, also not difficult to make a structure locally. Then balance of system, BOS components, for example, cables, connectors, tools, tackles, and many systems like a switch, isolators, and charge protecting device, whatever small things required for a PV system. So those are also, I think, so could be a good business. Then solution-based business that requires certain skill of designing a system, optimizing a system based on the customer's demand. So that solution-based business could be who can do the energy solutions based on the requirement or demand. For example, if somebody want to reduce the electricity consumption at their house, they can go for a grid-connected PV system smaller system probably. How big and how small it will be, that decided by the energy they use, consume. That could be one. So if there is a remote house, some resort or some farmhouse somewhere, or the rural people where there is no electricity supply or difficult to get a connection easily, so there I think off-grid solution could be another solution. Even I saw some villages in UP, Bihar, Orissa, even they have grid connectivity, but they still go for a mini grid because mini grid is more reliable uh, for energy supply. Because in many states, grids are still not reliable. So you have only 4-5 hours of grid electricity. Then if you are doing some business, or if you are doing some productive work that requires electricity or light or comfort or refrigeration, so then grid electricity is not really reliable still. So in that case, mini grid could be a good solution for those villages. There are many villages I have seen in Jharkhand, UP, Bihar. So mini grids are very popular there. Solar pump is another solution-based application, because you need a pump where you need water, and you need water when you have agriculture. Then what type of agriculture, that determines what type of water, how much water you need. So that I think people know better than much better than me. So solar pump is a solution-oriented product. I do not think solar pump is simply a product. You cannot use any pump anywhere. You need to choose a pump. You need to, depending upon the water source and depth of water, and also how much water you need, where the water will come from. So there are so many things that requires a lot of understanding. So that is why I consider the solar pump is not a simple product, but it is a solution-based, I would say, solution-based product or solution-based activity or project. So next, then come to energy business. So that you see a lot of power plants which are very big, some lot of megawatts or gigawatt being developed in solar parks in Maharashtra, in Karnataka, in Telangana, Andhra Pradesh, Rajasthan, Gujarat. So you have many large solar parks. So those parks are normally designed and developed to generate power and supply to the utilities. So now whatever you consume at your house, some percentage of electricity is also coming from solar. It's not always from the coal, because electricity have no color like blood. So it is just electricity. So some electricity is coming from coal, some electricity is coming from gas, some electricity is coming from hydro, some electricity is coming from lignite, and some electricity is coming from wind, and some from solar, definitely. Because now, as per recent statistics, so solar and wind and hydro, small hydro, together, we have about 23% of installation capacity. So if we consider about around 20% capacity factor, then probably it will give you about 5%, 4%, 5% of total energy. So whatever you are consuming, about 4-5% will come from the renewables. Solar maybe 1% or less. Now, the other sector is services. So there are many scope, definitely. When business is growing, then you have a lot of scope providing services. While you are developing solar projects, you need technical advisory services, then feasibility study is required, engineering design is required, then installation is required, there is also service, operation and maintenance is required, and also you need money, so you need also financial services. So banks are also doing better business in renewable today. So they are lending money to the developers. That is also one kind of services and business. So these are the things or areas where photovoltaic can generate business scope. Then depending upon your interest, your qualifications or knowledge, and depending upon your budget and business strategy or a career plan, so you can join any part of these areas, where you want to put yourself. Now I will just show you some applications. What are the main applications of a photovoltaic system? Many of you know already many things, but I will just show it for just to continue the presentation. So the first type of the systems are standalone or off-grid applications, which are very old practice. I think since 70s this has been practiced worldwide. Then mini grid and microgrid systems is a larger version of off-grid systems. That is also an old concept and then newly practiced. When you come to grid connected PV applications, which is now, I think, majority of the countries and majority of the business captures that grid connected PV applications, they are easy to build and less expensive in comparison to off-grid and mini-grid systems. So within the grid connected systems, you can see there are small distributed systems, maybe a small rooftop systems, and sometimes large distributed system, maybe a system over a large warehouse or a large building. And then ground mounted large systems, they are always large normally, except some mini grid or microgrid, they can also be installed ground mounted, because when you install a system in a village, maybe 10 kilowatt or 20 kilowatt, you may not find a roof or building in the village. So then you install in the ground. So then building integrated PV or BIPV, that is also another trend nowadays for introducing your PV module as a building material. The last one is very interesting. So Agro PV and agri-voltaic system. So people now started doing agriculture and photovoltaic together. That is why they call it agri-voltaic systems. That is nice concept to do, because PV system occupies a lot of land. So then there is always a conflict between food and energy, kind of, you know. So sometimes, of course, the land is not good for agriculture, then it is easily can be justified for a PV. But when the land is fertile enough to produce agriculture, then sometimes people will question whether it is justified or not justified. But if you can do agriculture and PV together, then both can survive together. The other one I have not, I think, mentioned here is floating PV. Floating PV is basically when you developed a PV system on a water body. So that is called floating PV. There are many pilot projects around across the world. Also, some small projects in India. One is in Kochi probably in Kerala. So another I know in Assam, very small one, only a few kilowatts. So that is one option. Then sometimes people also use the canals, not only water, but canals, covering the canals. Gujarat has that kind of projects. So those projects is an innovative concept using unutilized space or land or areas. For example, canal, otherwise it is not used. So you can have a kind of a bridging the both side, so you can have a solar panel just on the top of the canal. So if you don't have a navigation in the canal, that can easily be used. So if you have navigation, if you have boats or some ferries running on the canal, then of course you cannot use it. So those are there. And since PV is very flexible and they are always a modular system, so actually you can use and apply wherever you need energy in the form of DC or AC. So you can easily use PV. That is the beauty of photovoltaic. So it is highly flexible, highly modular, and highly adaptable. So you can make any voltage that is needed, connecting them in series. You can make more current, connecting them in parallel. So it is very, very flexible. That is the reason why photovoltaic is a very popular form of energy generation, and it is widely used across different sectors. Now I'll show you some pictures. You can see those pictures. The first one is street light systems, this one, and then this one is called a signal system, maybe roadside signal or maybe railway track. So this could be a garden light for fancy purpose. This could be a solar lanterns for portable lighting system. You can also charge your mobile. These are the little bit industrial applications like telecommunication towers, then mobile charging. So those could be, as I said, it could be a lot of variations in terms of capacity, in terms of, because you can easily design a system, photovoltaic system, based on your requirement. So it is not, that is why it is very, as I said, very flexible and very adaptable. Some more industrial applications, you can see offshore applications and also the applications for corrosion protection in oil industry. Some new applications, as I said, this one, that mobility, e-mobility. So these are all off-grid applications. You can have boats. There are large boats developed by one company in Trivandrum, so which has a 25 kilowatt system on the ferry, and then actually it is a battery operated ferry, so charged by the solar. So 90% of energy required by the battery is coming from the solar, because ferry has a large roof, so you can use a large PV system to charge the lithium-ion batteries it has. So it is the first Indian, I think, battery operated ferry which has been operation for last, I think, 2.5 years. So recently the ASEAN Development Bank, so they gave me an assignment to do a study for Maldives. I did, and I suggested that kind of ferry for use in Maldives. The Maldives is a combination of thousands of islands. So they did water transport from one island to another. For every single step, they have to go out home. So it is basically a ferry. So it will be very useful. Then the idea is that you bring your water transport to a green transport. That is a very ambitious, I think, thought. But I think it will also be reality very soon, because it is very convenient for that. And sometimes you can use those sheds in a charging station to charge a vehicle, a battery operated vehicle from solar. And sometimes you can have a fully solar like this. So these are, of course, you need a large surface to get a required amount of torque or the energy to drive and to provide a sufficient speed to the car. So that is why fully solar operated car is still a dream, though there are some solar like this one. So these are I think, made in Australia, many of them, and then they have a, I think, annual challenge every year. Some prototypes and small cars were also fabricated in MIT, Bangalore, which was funded by Tata. So it was a student project. I think they were very successful on that. But in any case, e-mobility could be another big area where solar can actually contribute a lot, whether it is a fully charged or partially charged, no matter. So you can always get current or energy to charge your batteries in an electric vehicle. Now, just see what is the mini grid system, or some people call it microgrid or mini grid, depending upon the size of the system. Smaller system is called normally microgrid, and big systems are called normally mini grid. So these are the systems where normally in India it is installed in a remote areas where electricity is either not available or electricity is not reliable. If you look at the European countries and US, so microgrid concept is different for them. So for them, it is a smart energy system to supply the energy demand for a society. For example, Google Office, so they have a microgrid system. So there's a highly, the same system, not different, but only difference is the control system and energy management system is very advanced. For a village, it is the same system, same batteries, the energy systems or control system are not that is advanced. Now, Maldives is having some kind of smart systems they're going to have. I'm working on it for Asian Development Bank is funding for that. So there will be, I think, even rural systems also will be quite smart enough in a couple of years. So these are nice systems and greatly benefiting the villagers where grid electricity is unreliable or very minimum supply or there is no supply. So, but these systems are giving them a lot of opportunity for creating jobs within the village for maintaining the systems, as well as creating jobs for productive activities, because those villages are deprived of doing business which requires electricity. Now they can have a rice huller in the village, they can have chicken farming, they can have water pumping for agriculture, everything they have now. So they are very happy. Now, small distributed systems can be installed in a building mostly. As I said, this is also a small system, but it is installed in the ground. It is for rural areas. But for urban area building, you can have a system just installed on the roof. So those are small distributed systems. Depending upon the size of the roof, so the system capacity will be determined. So then there are some large roofs like this. You can see those are also building roofs, but very large, maybe warehouse. So it can be some megawatts. Like largest rooftop system in India is in Punjab. I think they have about 12 megawatts in a religious, religious building. So it is the largest one, 12 megawatt. So ground mounteds are normally the large ones, which are normally built for generating energy and selling it to the utility grid. It could be some megawatts, 5 megawatts. It could be when nowadays, I think largest one is 2000 to 500 megawatt. So there's the largest one in India. So then the building integrated PV system, so it can be very different from each other because here what is important is the look of the building is important, design, as well as the what purpose it's used, whether it is installed in the wall or installed on the roof. Accordingly, your requirement, your materials requirement, your solar modules will be different. Of course, when you install on the roof, you not necessarily need a transparent roof, but when you put it in the wall, so you can have a transparent ones. So these modules are now available in different design and different shape and size. And these are basically building materials. And energy generation is a secondary here. Energy generation is not primary purpose. Otherwise, you could have, go for a full rooftop system for generation of energy. But here, primary purpose of this material is building material. Then it also give you some amount of energy. So these systems are not really providing the same amount of energy that you get from the this kind of systems. All right. Now the last one, Agro PV. So that is very interesting ones. Already the concept has been established and practiced in countries like Europe. In India also there are some small projects people has tried. I think Zain Irrigation has tried once with pump, and then I saw some building system with gardens below the solar panels. So those are there, but it has, I think, large potential, provided you take care of the safety issues which is required, because solar system is an electricity generating system, and farmer not necessarily be trained or understand the risk of those electricity that can cause electric shock or something. So that is why those precautions must be there. Of course, because you are using the systems in a differently, like you have a higher structure and more gap between the rows and all. So those will increase the cost of the system. So you have to definitely plan accordingly, so to make it more profitable, so that you can do agriculture as well as the energy both together. Okay, so now what are the phases that is normally followed while developing a solar projects? So there are mostly 4 phases in the life cycle of a project, solar photovoltaic project. The first phase is preparation and planning phase. So that is where you identify a project and you finalize a business model, what business you are going to do, whether you are selling energy, whether you are, which model, net metering, gross metering, and what. So that you decide. And then after that, you conduct a feasibility study. Whether it is a big system or a small system, you must carry out a feasibility study. Maybe approach and method could be different, but whether a solar project is feasible or not, that need to be studied at the beginning. The second phase is development phase, where particularly for a bigger system, so you go for taking the permissions from the required agencies. Then you select what kind of equipment you are going to use, which is suitable for the site. Not any solar is suitable for any site. So because the solar equipments are very site sensitive. So, and also site is very much design sensitive. So your solar system must be designed and equipment must be selected based on the site, not just based on what is available in the market. Because you can buy a best system or best equipment, but it may not work for your site. So that is why selection of equipment based on the site is very, very important. And then you look for money. So whether you use your own money or you go for a bank loan, so that will be decided here in the phase 2. And then you finalize the contract, who will install it. And then third phase is engineering, procurement, and construction. Here you actually spend money, you pay money, you get the things done, and you buy equipments and engage a company who will install, design and install the system. Then you go for commissioning the system. There are 2 types of commissioning, cold commissioning and hot commissioning. So then the actual work starts from 4th phase. So that is the longest phase, because operation and maintenance is required throughout the life cycle of the project. Though solar, it is very well popular saying that solar is maintenance free, which is not really true. Of course, it is not rotating. They don't have rotating device and machines and other things. So it is a less component which keep on running. But it is always exposed to sun. That is the biggest threat. And it is always exposed to the environment. That is another issue. So it will face all the environmental harshness and that impact of sun, ultraviolet rays and all. So it requires certain amount of maintenance. Of course, it does not require running fuel or something like that, but it requires certain amount of preventive maintenance, cleaning in particular, and how you are cleaning, what kind of water you are using, and whether using a what kind of brush or what kind of cleaning device you are using, what kind of nozzles you are using. So those are very, very important aspects as far O&M is concerned. And whether you are monitoring the system properly, that is also one option. And then do you understand about the performance of the system, whether it is really doing good, or if there is a deviation from the expected generation, what may be the cause. So those requires a lot of skill as well as a lot of understanding while operating and maintaining a PV system. Now look, what are the skill required in different business areas of PV sector? So I divided 5 sectors. So in manufacturing sector, R&D is one, that is a part and parcel of any manufacturing process. Then machine operators, of course, those could be different skill set. And sales marketing people, I think, are most popular people. So they go around and try to sell modules. Raw materials procurement is another skill set because the whole quality of module depends upon the raw materials they use. So buying raw materials is a utmost, I think, difficult and very critical activities in a manufacturers. So they need an expert for knowing the raw materials and then checking the quality and specifications and all precautions for storing those and all. So those requires a very specific and I think skill requirement. So that is where that is very important. Then process, whoever will be engaged for doing the manufacturing process. Then you need also administrative and accounts people, some and then management people. So as far business development is concerned, which is applicable to any business, maybe also manufacturing, maybe also in EPC business, maybe also a microgrid, mini-grid. So business development is a universal skill and also universal requirement for any business. But for solar photovoltaic or any technical business, one person must be knowledgeable to give the answers that the customer may ask. So that is why when a person want to do business development activities in photovoltaic industry, he must know about market policy, what is the market growth, so that he can speak about the market, he can speak about the policy. He should also be capable of drafting a tender for submission because some proposals will be submitted for the work, and he should be able to at least tell and judge whether the particular site is good or bad for solar and whether the system will be feasible, because feasibility study is must for any solar project success. So even BD people should be capable of telling the customer that yes, your site is very nice, but we have to, of course, we have to do a detailed study, but as of now it looks very nice or very bad or whatever. Then he should know about project economics, because customer will always ask you the price first, what is the cost, and then BD people, either he should be able to tactfully avoid that, or he should explain very nicely about the cost and how it works, whether there is policy, subsidy is there, concession is there, tax benefit is there. So those, a business development person should be capable of doing that. Liaisoning activities, of course, he has to or she has to do a lot of liaising activities with different government departments or individual customers. And he should also know about permits and clearances, what kind of permits requires, what kind of clearances required. So these are the skill set. He should also have some knowledge about contracts and agreements. So these are business development people skill. Then third part is pre-construction, before you construct. So these are normally little bit of high level skill. So one should know about the concept, what kind of system is more suitable for your building or for your land or for your water. So what kind of, how it work, and to fulfill your requirement. As I said, solution oriented concept. Planning is very important because a large number of solar plant fails because of wrong planning. That is very important and need to be done, of course, before construction. Then equipment selection is very important based on the site, and then how do you do engineering, procurement, and construction planning. And then engineering design is done before construct. Then procurement is also done, and project management done. So these are all the skills or required before the construction starts. Once the materials are at site, so your construction begins, that you need a site engineer to supervise your activity and make all logistic arrangement. Then you need installers, which are skilled, technically skilled people. Then you will also have workers, who is not necessarily be skilled, but definitely have basic knowledge. For example, how to handle a solar panels. So if you handle a solar panel in the wrong way, so you will create micro cracks on the modules. So it is very important. Even the workers need to be trained. Who will train them? The engineers will train them. So engineering people should know about very small and very nitty gritty of the all activities. How to handle a module, how you will engage workers and instruct workers or give them training, how to carry them, how to store them. So those are very, very important aspects for overall success of the solar panels plants. Security is the one, and then management support. And in terms of operation and maintenance, so monitoring and evaluation is a major part, because you need to monitor the performance of the system more or less daily basis, or at least a weekly basis. And if there is a deviation between the input and output, for example, you saw that there are enough sunshine, but there was no production on during this time to this time. So what might have gone wrong? So that determines what kind of maintenance or troubleshooting required in the system. So that is why monitoring and evaluation is a very important aspect, particularly when it comes to a larger system. Then, of course, equipments require regular maintenance. Your modules require cleaning. Your inverters require cleaning, and also structures and other things requires preventive maintenance. And then you need also security, and then overall technical management. So these are the skill set or areas broadly you can make, or you can see the to complete a solar photovoltaic project. Now I will just give you some statistics why PV system fails. So there are some studies that indicates that 55% false is because it's wrong installation. So that is a big eye opener, because see, it is very true. Most of the problem or most of the mistakes are made during installation, as far as solar is concerned. Because problem of solar is it's not like a single equipment like a diesel generator or some hydropower plant, where you install a hydropower plant, you will be so precise, while you are doing the balancing, while you are doing the leveling and everything. So only expert will come and they will install, test, and monitor for some time, and they will leave. But in solar system, because they are a small system first of all and spread out in some watts, and then it it became a megawatt, kilowatt, and all. So the cost of the system itself, investment of the system itself, does not give you a lot of scope for engaging a very high skilled people for small work. So that is the main issue as far as solar photovoltaic systems are concerned. So normally also the people are not experienced. They do not know how to handle the modules, how to do this and that. So they end up doing something because they also think it is very easy work. So they end up doing things of their own way, and then they, of course, made the mistake. So that is why globally, I think majority of the fall, more than 50% fall, is coming from installation, wrong installation. But very interestingly, 25% problems are coming from design and documentations, and also planning faults. If you look at these other small parts, the product defects are only 9%, maintenance is only 5%, environmental influence is only 5%, miscellaneous theft and others is only 1%. So 25% and 55%, that constitutes, I think, 80%. 80%. So 80% problems are coming from human error, because installation is done by human, because solar system you cannot install by robots till now. design and documentation planning is done by human. So that is why 80% problems are related to human intervention. That is why it is very important to I think develop the skill and proper knowledge among the people who are involved in solar industry, and then it will give not only the industry a benefit but also the in country and people as a whole. That is very important. Then another example you can see, even you install successfully some systems they are all on system operating, but your performance is very poor. One is system failure here. You can see very poor performance. Some plants are operating at here, which is the highest. Some plants are operating here, and there are a lot of variations. And these all 30 systems are installed in the same city, New Delhi, and then they give all different type of performance. The reason was many reasons. You can see those reasons. Soiling or the dirt is one reason, shedding is another reason, cracks in the cell is one reason, PID effect is another reason, or installation. Most of the things are related to installation. For example, soiling is a maintenance problem, of course. Near shedding is an installation problem because you have not done proper shadow analysis. Cell crack can be an installation problem because you have not handled the modules properly. Potential induced degradation, a design issue. Deviation from source, installation problem. Inactive cell string could be a maintenance problem, also could be a design problem. Inhomogeneous tilt angle is an installation problem. Disconnected circuits is probably installation problem. Inverter clipping could be a design problem. Similarly here also, these are the same thing, but yeah. So I can show you some pictures now as a case. So these are the problems. So you can see shadow is a problem. Here, of course, the person committed to trim the tree, but he did not. So this system was lying like this. Here, you cannot do anything now because it is an RCC building, you cannot demolish it. So there will be some shadow problem here. Here you can see the installer was too ambitious to install more panels. So he put the panels inside the building. So these two panels will be never used. And then if they are connected in series, all of them will be not used. Here you can see because of the height of this wall, these modules will always have shadow from in the morning, at least up to 10:30 or so. So you lose a lot of substantial amount of energy. So poor planning, you can see the modules installed, then there's a water logging, there's a soil erosion, and then there is a damage to the structure. Then poor quality materials, that purchase was not correct, or you have not done proper due diligence while you are procuring the materials. Then of course these are fault of installation, you have not properly fixed them, then there's a lot of water ingression. You have not protected the cables, so cables are damaged. So when cables are damaged, there could be fire. And if you don't have access to the roof, so you actually can cover up the solar panels with dust. So then you lose all the energy. So you don't know how to stake the modules, so you keep on staking them one after another. And now imagine there are mostly about maybe more than 100 number of modules here. I think here there is a 128. I counted, I forgot the numbers, but in any case, one module has a weight of about 25 kilogram. So if you are staking them, say 100 modules, so it will be how much? It will be 2.5 tons. That is 2 cars, two cars on one of the, or maybe a tractor. Oh no, not tractor, maybe a truck, small truck. So then what will be the condition of the modules at the bottom? So it will be facing 2.5 tons of minimum that weight, and then do you not expect that the module will be in good health? That is not true. So staking is one of important aspect. So you should not stake modules like this. The other aspect is handling, how to carry the module, because the module glass is quite tough because it is a toughened glass, but the cells are very brittle. So the cells will be broken. You will not see them because of the toughened glass and laminations in the backside. Those cracks will be not visible for naked eyes. But when you do a electroluminescence test, then you will know that those modules has gone. So then those will be highly degraded over a very short period of time, and module will be dead in very short period of time. That is another reason of developing cracks. So these people have no idea what they are doing it. So that is why they are doing. So you need proper understanding. That is who will make them understood, because the people, qualified people who know these things, need to communicate with them, train them, instruct them what to do and what they should not do. Because if they use modules, if they work on the modules, even it is not required to work, of course. Here I can understand that this guy, he cannot fix the modules here, so he cannot reach out from this side. Probably that is why he is climbing. Of course, he does not know it. So, but definitely that is not a good idea. And then this will bring your investment to zero. Right. So, what are the risks in developing some solar projects? So, number one, the risk of low performance or poor performance. So, what is the areas for mitigating those risks? So, proper site assessment, proper design, and proper installation and maintenance. I think all phases of activities is required. Then second risk is risk of failure and interrupted plant operation. So the system fails, it doesn't work for a month or so, your inverter may fails. So how can you mitigate those risks? Definitely by buying quality equipments and balance of system equipments, which are equally important, because you look, the cables and connectors are very important part of the whole plan. You can buy the most expensive modules and most expensive inverters, but finally you are going to connect those modules by a small piece of cables. If quality of cables are not good, then your whole modules will not work properly, because your energy generated by modules will be just lost in the cables. Or if there is a loose connections because of poor quality connectors, then loose connection can cause spark in the joints, whether it is series or parallel, and then you just create some fire, and that can actually translate into a big fire, which can damage the cables, which can damage the modules, which can damage the junction box or combiner box, which can damage the inverter, and which can also cause a fire for the house. So that is why BOS is the most important aspects, and then one has to be very careful and very mindful about selecting and fixing the BOS. Not only selecting the BOS, again, as I said, because installation is the most important part. You can again have a good quality BOS, but if you've not done the proper joint, for example, if you're not used the crimping tool, so you just use the pliers to connect them or crimp the two connectors, then again the same problem will happen. So use of proper connectors, then use of proper tools to connect them is very important. Then of course the proper design, proper installation, proper maintenance. So those will only reduce the risk of failure and interrupted plant operation. So the third risk is the faster degradation. So sometimes actually modules, PV modules will degrade over a period of time. The life of a solar panels are considered to be 25 years based on the guarantee provided by the manufacturer that the modules will produce at least 80% of its capacity. Or if you buy a 1 kilowatt system, the capacity of the system should not be lower than 800 watt at the end of 25 years. So that is the life of the system. Now, that is not always true because of the module. Sometimes modules quality is so bad, so it can actually degrade much faster than it is guaranteed. So if you have a guarantee, probably you can claim the guarantee. Then also they will ask you a lot of questions, because guarantee and warranty will be void if you done a wrong installation and if you done a wrong operation and maintenance. So you bought a good quality module and you have a warranty for say 25 years with 80% of power, and then module, you suddenly realize that module got degraded much faster, and then you approach the manufacturer. They will first come and check your installation, then they will come and check your operation and maintenance, how do you maintain it. So if they see you or know that you are climbing on the module to clean them, then they will, your warranty will be void. And then if they will see that your modules are coming under shadow, whether it is small shadow or big shadow, then warranty will be voided, because module may cause the hot spot because of the shadow, and because of that your module can be damaged. So your degradation, definitely one is quality of PV module. If you buy a good quality module, then the scope or possibility of faster degradation is less or nil. But proper handling and maintenance of PV modules or installation is very important, because that ultimately can give you guarantee of whether a good module remain good or not. If you buy the best module, then you jump on the module because you in the joy, because you bought a good module or solar panel, you are happy about it, so you walking around it, so then your module is no more good, so that will degrade very fast in a couple of months. Then risk of fire is another big I think challenge. Then it can cause plant and property damage. Of course, if you have a rooftop system, then you can that fire can translate or transmit to the building. If you have a ground mounted system, sometimes you lose your inverter, not because of the inverter got burned, but your cable got burned, then the fire catches the inverter. So then you lose the inverter. So I have seen many examples like this. So your connections at the inverter point is not good. So that is why it became loose. And then loose connection will create arc, because it is particularly the input side where DC arc is very strong. And then it catches fire and then it damages the entire inverter. So BOS selection and installation is the most important. Of course, proper design, regular inspection and monitoring is important. So one is your design should be correct, but it is done in the drawing room. So that has to be translated into the field. So proper design will be translated. That means you have to install the system as per design, and quality of BOS, balance of system, equipment should be must be good, and installation quality must be good. But sometimes when you install a system and it is operating for a couple of months or years, then there may be changes because of the wind, because of the some extra elements, because of the monkey probably. Monkey will come and may cut your cables. You do not know them, what they will do. Your vermins or some other insects can also damage your cables. Mostly cables must be protected because cables are and connectors. These two things are mostly cause of fire and hotspot at the end. Then the last one is risk of electrocution, which is really need to be taken care of, because any electricity system which is above the 120 volt or so needs to be protected. It must have an earthing system, and then for any eventuality of leakage of voltage or current, so then it should not affect the persons, particularly when there is a broken module or connectors which is exposed to water, then not properly tightened, then water reach out those joints, metallic part, and then there will be leakage of current to the structure. And then one person, cleaning person, he was spraying water, and then he come into contact with the structure, he will touch them definitely. So then he may got electrocuted. So those are the important, very important, and awareness also equally required, because earthing system is not an active electric system. So people underestimate the earthing, because once you install a system and put everything in place and then you switch on the inverter, it will work. You don't need an earthing system to work the inverter. In some cases, inverter earthing is a different thing. So people take care of the inverter earthing, but I'm talking about the electrocution. So that is basically happen in the structure. So then people don't care about the structure earthing. So then only it can happen, the sad thing can happen only when there's a leakage. But people don't know about it and don't foresee about it. So they either they do it very poor earthing, sometimes they don't do it. And even it is required from the tender or something, they do it, but sometimes they forget to connect them properly. So which is very dangerous. And since DC electricity is actually it's a straight electricity, so you don't have a chance to second chance. You don't give you a shock, but it will just kill you instantly. So that is the, I think, last point that I wanted to make. So now, how you make a project successful? So you need 4 elements. So as you know already from discussions last 1.5 hours almost, so that hardware is important, your products are important, your inverter is important, your modules are important, your cables are important, connectors are important. So all hardwares are very, very important. Those has to be of good quality. So then second is practitioner standard. Who will install? The installer, the designer. So those people must practice good things. How they will practice good things? They will learn good things. So they will learn the correct things. They will follow the correct standards, and then those can be availed from a good training or university where it is learned. So it is responsibility of like institute like yours, so that you actually transfer the correct knowledge to the student, so that the students are equipped to work in the industry in a in a proper and professional way, as well as the proper way, I would say, and safe. And then those together will make the whole thing successful. But of course, you need a support from the management. So management also equally responsible for buying the hardware, good hardware. They're responsible for engaging people, and then training them what to do and what not to do, and they should arrange it. So this is the last one is for the companies who actually develop the projects. So their management should be must. But as a university, what your role is basically provide good training and provide correct knowledge and correct information and opportunity to the students to learn in the university itself through practical and through proper instructors. So that is all from my presentation. Thank you so much for your patient hearing. So now we still have a lot of time, and then we can discuss based on your questions or inquiries or any clarifications that you want to have from me. Thank you so much.
Thank you, sir. Now the topic is open for the discussion. So I request all the participants to raise your queries. You can put your queries in the chat box, or you can unmute yourself and discuss with the sir. I request participants to raise the queries. Participants present in training hall, they can also raise queries.
Very nice presentation, sir. And you have covered all aspects. Sir, it is very good opportunity for learning our business. But sir, the cost of solar system is very high. So it is not adopted by all the local farmers or any other. So what is the reason behind it? Why the cost is very high of this system?
Actually, I have not heard the questions clearly. Can you repeat it, or Swati, can you repeat it?
Yes. Sir, please repeat your question quite loudly.
Yes, sir, your presentation is very nice, sir. You are cover all aspects. But sir, solar system, the cost is very high. So many farmers cannot adopt this system. So what is the reason behind it? Very high cost.
Okay, yeah. So see, the solar system was high, cost was high, not is high, of course, but that all depends on the economy of the buyer or whatever. So as far energy cost is concerned, so see, the issue is when you buy a solar system, you actually buy the generator. But when you buy electricity, you don't buy the generator, you just buy the electricity. But solar, you buy the system so that it generates electricity. But if you look at the life cycle cost of the electricity generation, nowadays it is much cheaper. And in many cases, it is cheaper than coal actually for large scale. But definitely you are right, as far as investment is concerned, that requires investment. So that is why, so you need the money. But as far as farmers are concerned, definitely there are large subsidy for solar pumps, probably I think more than 50% subsidy, and there was some lease finance scheme where one person can take a pump lease and not really buying them, but at a very small price. So those schemes are there, but I still believe that those are small in numbers, so they cannot cover the whole all customers, but I think still some people will get benefit out of it.
I want to ask question. Am I audible?
Yes, sir, you are audible.
So it's a very enlightening presentation, sir. Here, being as a stakeholder of agriculture and city, our main focus is to the betterment of farming community. So if you want to build a business areas, you have shown the 4 business areas, that is product-based, solution-based, energy-based, and services. So looking to that, if you want to build a business area regarding solar photovoltaic for the farming community, how to integrate this business area to double the farm income for the farming community?
Yeah, so now some farmers agitations are going on in Delhi. So there is a different thing. Yeah, but I think solar PV, what my presentation covers was basically opportunity for the people who actually looking for careers. So as far business is concerned, so business can be started in any areas, of course, but depending on the person's financial capability, what he can do. So it is in somewhat, in solar, it is easier for a person to start a business based on his capability in terms of knowledge and experience. So now if somebody want to invest for a manufacturing plant, that is definitely not a cup of tea for many people, because that requires a lot of investment. But if somebody want to install a say for example, for a village context or rural area context, somebody want to servicing. So he want to start a O&M company, operation and maintenance company. So then that requires hardly any investment. So only requires skill. So he has to know what to do and what not to do, of course. And then very minimum equipment and minimum tools. But mostly it is a knowledge driven. Similarly, engineering, procurement, and EPC business, many people they start with a very minimum investment. There also you don't need really investment as such, but you need the skill, that is business development skill. So if you bring business, so you get advance, and then you take money from the investors to the product supplier. So you just get the money and then install the system. You make the profit. So those skills are required. One is skill is very important for people who are doing business, and then so businessmen will do that. As a training organization like us or university like yours, our duty should be give the people a correct knowledge which is applicable to the industry, and then then you leave it to them what they want to do based on their investment capacity or intention. Some person may be interested for some R&D work, or maybe some high level consultancy work maybe. So depending on the person's intention and background and other things. For example, I told you the two persons from university work with me. I found them very knowledgeable, and they are very smart guys and doing very good in the industry. So but that is why I think we should focus, because otherwise the whole sector is very large and very big. So we should focus what we can do in our own areas.
I will put this. I want to add these two and put into the other case that if I am a farmer,
right,
and I have 4 acres of land, and I want to build this solar photovoltaic system in 1 acre as a business. So is it feasible project?
No, that depends on two things. One is first of all, if somebody, I think few days ago, one person from Solapur, he called me and he asked me, he has 13 acres of land. They are not using it for cultivation. So can he use for developing a solar plant? So then my suggestion was, first of all, when you want to build a solar plant, so you have to understand at which area of business you are talking about, right? So mostly it will be if you have a land piece and you are definitely a farmer is not going to consume the all energy, because he don't need that much of energy. So 1 acre land probably he can develop about, I think, 300-400 kilowatt system. So that energy he may not require that energy. So he have to sell the energy first. So in business, that is your product. Right? Your energy is your product. So now you have to find a customer who will buy your energy, first of all. So it is not easy, for example, in India, because you have to give the energy to the utility grid, and somebody has to take somewhere. So those are technical issues are there. So it is not simply a buying and selling a product, but it is there is a lot of technical issues as well as the policy and the permission issues are there. So that is the main issue. So you need a customer, but forget about 1 acre. You say somebody has a 13 acre, 14 acres, so he can develop 3, 4, 5 megawatt system, and then even then he has to find a customer who will buy the electricity. Because electricity can be generated, that is as per law, right? You have every right to electricity that you can generate as per your choice, but what you will do with the electricity you generated, that has to be sold. But that is the problem. So selling electricity in India basically happens through utility companies. So you have to sell it to the discoms. They have to agree to buy your electricity. At what price? That is the next question. So the price at what the utility want to buy the electricity, whether it is profitable for you from the financial analysis point of view, investment point of view, it is one. Then another option of selling electricity is the third party. So if there are another party, for example, there is a industry in Mumbai who want to buy electricity, you can still generate electricity in Akola or Solapur, and then you sell it to a person who is sitting in the Mumbai, or consuming energy in the Mumbai. For example, there are I think some 500 megawatt plant which was installed in Telangana. So their energy is consumed by Delhi Metro. So this is called third party arrangement. So that is also possible, but that again requires a lot of professional activities on that. So there are some projects, even 5 megawatt, 3 megawatt, 2 megawatt projects. So those projects are there where third party they buys the energy.
But if it is a workable model, then whether it is cost effective, it will benefit to the
Yes.
level.
It is cost effective depending on your negotiation skill at what price you are selling the energy. For example, if you know, bigger system generally has a less generation cost. For example, if you develop a 5 megawatt plant, your generation cost will be about 3 rupees or 2.5 rupees. Then if you can sell it as a 5 rupees or 6 rupees, then you can make business out of it. But if your negotiation skill is not good, then you end up negotiating it to selling at the same price. Then there is a risk because you do not know, because today you are estimating the energy. Tomorrow that may vary a little bit because of the weather, because of whatever reason.
If you consider it as a farm product, so in a policy level, farm products should be a minimum support price.
Right. So your electricity should also have a minimum support price. But that's true. But that will be, I think, that will come under industry, not under agriculture. It will come under power sector.
Sir, our institute has installed on grid connected systems, sir.
Yeah.
It has been observed that when the power is off from electricity board,
Yeah.
it is also not getting to the instrument. Why?
Right. Because that is the, I think, the requirement of a grid connected inverter. Because in some cases, for example, in your institute, you have a grid connected inverter system and connected to the grid. Now, electricity may be interrupted for two reasons. One is load shedding, so your power is cut at the substation. The other one is you can also cut the power locally for maintenance purpose. For example, suppose you have switched off the grid for maintenance purpose and solar system is still active and it is generating the voltage. What will happen to the person who is doing the maintenance? Right? So then there will be an accident. So that is the reason why as per, it is a worldwide policy, it is not only India. So when you have a grid connected system that you have an active inverter connected to the grid, inverter should immediately within 2 seconds should be disrupt or should be switched off, disconnect from the grid when there is a difference in voltage at the line. So as soon as you switch off the line, the voltage becomes zero and then your grid connected inverter will be disconnected within 2 seconds. That is for the safety purpose. But if you really want to use that, then you need a battery backup. Then you need another inverter and control system. So which will then shift your power to the battery operated system. Then whole system will be isolated from the grid and that they will work as an independent system. So that is how. The another way of using PV when there is no grid is a diesel generator. So if you have a generator running at your campus and your grid is not there, the grid from the generator, the voltage from the generator can be used to operate the PV system. But in that case, your energy or power produced by the PV should not exceed the generator power, because if generator power is less than the power generated by the PV, and that consumption is low, then PV power can go back to the generator and it will damage the generator. So then you need a protection system in the generator.
Thank you, sir. Thank you.
Okay, thank you, sir. So, any other question from the participants who are present at the online platform? If you have any question, you can raise your hand or you can unmute yourself and discuss with the sir. Okay, I think there is no question. So thank you very much, sir, for joining us with us as an eminent speaker for the today's session. You have very nicely presented on the topic solar photovoltaic technology and its entrepreneurial prospects to build the green India. The topic has been covered very well. Like points like scenario of the global PV market, employment generation in the PV industry, entrepreneurial prospects in the PV industry, advances in photovoltaic system, planning and management of the solar projects, why solar PV project fails. A very good presentation, sir. Once again, thank you very much for joining with us. I think our participants are now well aware of the solar photovoltaic based entrepreneurial prospects, and we are sure that they will definitely encourage our agriculture graduates to go for the solar business. So thank you very much, sir, and thank you once again.
Okay, thank you.
लाईट लागलाय